Hi, I'm an old guy and I do maths. And here we have a set of letters, the first 6 letters of the alphabet. And our question is, how many 4-letter arrangements can we make out of these letters? A, if we only use the letters once. So that means, for instance, we couldn't have AABC. We'd have to have ABCD or DCBA, because order is important, because we've talked about an arrangement. So this is not a combination that we're talking about, it's an arrangement. An arrangement is a synonym in maths anyway for a permutation. So that's one of the first things that you need to work out, whether you're dealing with a permutation or a combination. And in permutations, order is important. So AB is not the same as BA. When it comes to combinations, AB and BA are the same thing. Okay, so if we only use the letters once, it's a fairly straightforward problem. That's not to say that B is not a straightforward problem as well, it's just a different problem. So, how do we go about this? Well, we set up our permutation in PR, that's in this case 6, and we're allowed to choose 4. The formula for this is 6 factorial over 6 minus 4 factorial. It's very straightforward. 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1, which gives us 6 times 5 times 4 times 3. 6 5s are 30, 4 3s are 12. That gives us 360. Sorry, let's get that into frame. 360 possible permutations. There. See how easy it is? This is a permutation. That's our answer for A. Now, if we can use the letters more than once, that means potentially that we could have A in a set, or B in a set, or AA, or whatever. So potentially that means that the whole field is wide open all the time. And indeed that is the case. This is our answer, and this is how you work it out. How many letters do you have to choose from? 6. Second choice. How many letters do you have to choose from? 6, and so forth and so on. There is no implied non-replacement here. If you think back to problems where you had marbles in a bag, 3 red, 3 white. If you replaced them, the probabilities remained all the same as to whatever time you picked out a marble. If you didn't replace them, things changed. And in this case, we've got no replacement. Order is important. And so it's 6 choices times 6 choices times 6 choices times 6 choices. 4 of them. And the answer is 1296. If order were not important, this would be a much smaller number. It would be this with the addition of 4 factorial in here, which would increase the denominator, which would make it a smaller number than this. And that is that's critical. That's really critical, understanding whether you're dealing with a combination or a permutation. Anyway, in this case we're dealing with a permutation, an arrangement. Order is important. Thanks very much for watching. See you next time.